Hello there, this is Mark Summers again from Summers Technical Services. We're going to start a new series of videos to discuss the Assignment 6 RF load tray. So the first assembly, or the first video, will be discussing how we create our assembly model, which will eventually look something like this. These are all the parts that all the team members have been making, plus the fasteners, plus the parts I'll be giving you for free. And we'll also be going to the configuration manager and learning how to create an exploded view with these exploded line trails, I call them, and we'll be using that exploded view to make an assembly drawing, which will be the third video. And it'll look something like this with bill of materials, balloons, quantities, all the descriptions. And then the second sheet will have an overall front top side view with some reference dimensions. So let's go get started. I guess before we get started, let's talk about once you get done with the assembly model, you're going to want to clean up your tree a little bit. And these trees get really crowded. On the simple parts we've been making so far, the tree is not near this big. And so when you get all these parts on there, it's going to be nice if we kind of clean it up. So let's put these parts in order. Here's the -1. For some reason it's down at the bottom. So you just drag it up, and I'll put it up here right before the -3s. And there's the 1, 3s, 5, 7, and geez, some reason the 9 is down here, so I'm going to drag him up. And that'll just make it easier to find the parts. It doesn't change anything, it just kind of cleans up the tree. Another thing you can do is all these fasteners, maybe I like to group these things together, and so you can do something like this. You can drag them and get them all in order. Here's 4 of them. I'll control click all 4 of these, and then right click and then select, where is it, add to new folder, and then give the folder a name. That's logical. And then now that folder contains those parts, and if you want to take them out, you can drag them out. If you want to add more in, you can drag them in. And that'll help turn your assembly model from a good model to a great model. All right, so maybe that'll take care of that. Now let's go over here and start a new assembly model and see if we can learn some techniques for assembly modeling. All right, so we're going to find the inch assembly template. It'll be empty. And the first part we place is going to be the part that you would place first if you were building this in your garage. And so in my mind, the only obvious choice for the first part is that base plate, because all the other parts all kind of bolt to that main plate. So I'm going to place that one first under Insert Components, and I'm just going to click on the screen and place it. Once you place that first part, it fixes it and ties down all 6 degrees of freedom. And you'll know it did that because there's an F in front of it in the tree. The F means it's fixed. And it's fixed, which is a good thing, but it's really a bad thing because it's fixed in some oddball location that I don't know. I want the planes of the part to line up with the planes of the assembly, and right now they don't. So every time you place your first part in your new assembly, right-click on that first part and float it. That'll put the minus sign in front of it, and now it's completely free to move in all 6 degrees of freedom. And now we can tie it down. And the way I want to logically tie it down is because I put my planes on my part in a logical location. This is going to be the way to go. So I'm going to grab the front plane of the assembly, control click the front plane of the part, and hit mate. And I can choose what kind of mate I want, but Solidworks generally does a good job of deciding what mate I want. And so it's decided I probably want a coincident mate with no offset, and so that's exactly what I want. And if it guessed the wrong way on the alignment, I can click anti-aligned and it'll flip it the other way. But since it guessed the correct way the first time, I'll leave it like that. I'll say OK to approve it, and I'll say OK to get out of this command. So double middle mouse wheel to get my exploded or my view full and screen. Now that minus sign is still there. I still need to put some more constraints. I want to mate the top planes. Top plane goes right through the middle of the part. So when I hit mate, now I guessed correctly that I want a coincident mate but it's guessed incorrectly about the orientation. These slots on the top, these need to be on the bottom. So I'm going to flip that direction. Excuse me. And I like that much better, so I'll approve that. Now the first plane, as we talked in class, the first planar mate got rid of 3 degrees of freedom. The second planar mate got rid of 2 degrees of freedom. Now we only have 1 degree of freedom left, and this last planar mate will take care of that. So right plane to right plane, mate. Now that minus sign will be gone on the part in the tree because it's now fully constrained because all 6 degrees of freedom are now tied down. All right, now we just choose the next part we want to place, and the logical choice in my head is this big RF load because that's the part that a lot of other parts mount to, and so to me that's a logical choice for the second part. Remember, on these parts I'm giving you, these step files, I'm going to give you these 2 NARDA parts as step files. You need to, before we do any assembly modeling, you need to open up the step file, to verify that the error checking, do not do feature recognition, and then save it as a Solidworks part, and then place that part in this assembly model, not the step model. So here is the RF load. I'll click on the screen to place it, and we need to tie down 6 degrees of freedom. So the first thing I would do if I'm assembling this thing for real is I would take the bottom surface of the load and I would mate it to the top surface of the plate. So I'll hit mate, and it's going to guess I want a concentric mate, which is what I want, and I'll approve that and say OK to get out of the command. Now what I want to do is, again, I want to do what I would do if I'm building this thing. I would line up this screw hole here with the hole in the plate that it's going to mount to. And so I'm going to select that first cylindrical feature. I'm going to control click the second cylindrical feature. And when I hit mate, it's going to assume that I want to line up the axes of those 2 holes. And that's exactly what it does. And I can see that that's happened. And I'm going to approve that and say OK to get out of the command. Now 1 planar mate and 1 cylindrical axis hole line up. That got rid of 5 out of 6 degrees of freedom. And now the last degree of freedom I can tie down by lining up this diagonal hole here at the back. So I want to go across the other side, zoom in here. I'm not grabbing this edge, I'm grabbing this cylindrical feature. So I'm going to click that one, control click that cylindrical feature, and when I hit mate, it's going to swing that thing around and line it up and get rid of that last degree of freedom. OK to approve, OK to get out of the command, and now that minus sign is gone. So let's just keep going. Seems like the next part might be this NARDA adapter. Insert components, browse. If I had the parts already open, they'd show up in that tree, but I don't have these parts open, so I got to go find them. They're all in the same folder. Make sure all your parts stay in the same folder like we talked about early on in the semester. All right, so this one's got minus sign, 6 degrees of freedom are still loose. You got to make sure to look on the data sheet to find out which end of this connector, which end of this adapter goes where. You don't want to get it on there backwards. So I'm going to make that cylindrical feature to cylindrical feature. That means those axes are lined up. Now, I don't know how far this thing threads in. This is a threaded feature here, and those mate together, and it's some unknown distance. But I've already designed this plate such that the in and out location is going to be defined by the standoff. So when you mount the standoff in the middle of that slot, and the top male portion threads into the bottom tapped hole there, that will do that last location front to back. But there's still one other degree of freedom I haven't tied down, is this rotation. So I don't want that thing to rotate. So I can do another mate. I can select this top face, control click this bottom face or the top plane, either one. If I mate those together, it cannot make a concentric coincident mate because that would break the axis alignment. And so what it does instead is it assumes I want to do a parallel mate. I want those 2 planes to be parallel, which is correct. So the minus sign is still on there. on this part because it needs those standoffs, and I'll just leave that loose for now. All right, let's add the last part, and then we'll put some fasteners on here and call it good. So let's go to insert components. Let's put this handle on there. And so the handle, I think, was the -1. And if it pops up, maybe. Did I hit the button? Maybe not. Here we go. Browse. Go find the -1. Looks like it right there. And then I'll click on the screen and place it. It's got it backwards, but I don't care because the mates are going to take care of all that. So the first thing I'd do is, if I was assembling this for real, I'd grab that handle and shove it and touch off on that face. So I'll mate those together. See if it flips it around. No, it didn't. So I guessed incorrectly, but that's okay. I can flip it and approve that. And I'll just stay in the command, and I will now grab this cylindrical feature here. And I will control click this hole over here. And that will line up those axes. If I can get me a... There we go. Have both features in the tree. I'll prove that. And now I'll get out of the command and we'll take a look and see how many degrees of freedom are left. One planar mate and one axis alignment. It's only got 1 degree of freedom left. It can still rotate. And so I'll come over here and grab this cylindrical feature. And I'll grab this cylindrical feature, control click it. And I could grab the outside cylinder, it doesn't matter because they both share the same axis. But it makes logical sense that the hole is lined up with the hole. So I'll make those, and that minus sign on the handle will go away because now the 6 degrees of freedom are all tied down. And there we go. So now maybe the last step, we'll put some fasteners on here to learn how to do that. So I'll hit insert components, and I don't remember which one of these washers is the right one, but you can ask your team member, whoever made the handle will know what washer and fasteners use. How come this thing is not, here we go. Browse, and let's see, I don't know which one of these it is. 48. I don't know which one it is. That looks like the fastener. I don't know. I'm not sure which one of these is it. Alright, there's a split lock washer. We'll pretend like that's the right one. Alright, so now we're going to mate this. This face here, this red plate tells the washer where to go. So that face, control click that face, mate, and see if it guesses correctly. Look at that, it flipped it around. Solidworks is pretty smart. That thing is on the correct side, so I'll approve that. I'll stay in the command and I'll select this cylindrical feature. And then I'll select the other cylindrical feature. Control click it. And when you do this concentric mate for the fasteners, it can still spin. And to keep that thing from spinning, you're going to want to click this lock rotation button. And that'll tie down that last degree of freedom without having to do a separate mate. Okay, so that one's done. Now let's place a fastener and see if I can figure out which one is which. It's one of these guys here. I'm not sure which one. I don't know. Let's try. I don't know. Whoever made the handle will know, so ask them. Oop, that's not it, is it? Let's try another one. Insert component. Browse. That looks like the one for the standoff. 148. 51. Maybe that's it. It looks a little better. Alright, we'll assume that's it. We'll delete this one for now. And so now we want the washer tells the fastener where to go. It's the way I look at it. So that face and that face mate. We'll approve that. And then we will do a cylindrical feature with a cylindrical feature. I'm not going to grab this thread because it's too complicated. I'll just grab the head of the screw. So that's cylindrical feature with that cylindrical feature. That mates. Make sure to lock rotation so that all your degrees of freedom are all tied down and the minus signs are all gone away. Alright, so I got to do that again on the other side. It's going to be a pain in the neck, and I don't want to do it because I'm lazy. So let's show you another trick here. I'm going to select the fastener. I'm going to select the washer. Control click the washer. Now I've got both of them selected. And I'm going to go insert components, but I'm going to use a pull down, and I'm going to say copy with mates. So since I pre-selected the two parts, they're already in the blue box, so I can go next. And now what it's doing, it's asking me that the mates between the two parts are going to automatically get added to the new pair. This is asking me what to do with the other two mates. So this was the first mate for the washer to the plate. I don't want to repeat it. If I did, I'd check repeat. I don't want to repeat it. I want to replace that first mate with this mate over here. So I'll click that face, and that'll put that face in the blue box over here. Now it popped down to the next one. I don't want to repeat that cylindrical mate on the other side. I want to change it to that cylindrical surface right there. Pulls both sets over. I approve it. And then I'm done placing pairs of those things, so I'll get out of the command. So I highly suggest doing that on these stacks of fasteners, especially like the ones for the bottom plate. You're going to have two washers and a fastener. Do the stack just like I did here. Select all three. Copy with mates. Boom. You can do them much quicker than doing them individually. All right. What else we need to talk about? So you can add the rest of the parts. As you're assembling this thing, when you see errors, if things don't fit, if fasteners are too long or they're the wrong size, you need to catch that as you're putting your assembly together. You want to catch errors while you're doing your design, not when the thing has been fabricated, all the parts are on the manufacturing floor, and somebody calls you on Sunday afternoon and says, hey, the washers are the wrong size and these parts don't even mate together correctly. You want to find that out while you're doing your design, not later. So as you find errors, that's a good thing. Bring them up to your team members. We'll correct the models, or you will correct the models as needed, and then get new copies to everybody, and then move on. All right, so one more thing before we get through with this video and then start do another video on the exploded view. Let's talk about how to do these colors. When you do all your parts, all these custom parts we're going to be making, they're all aluminum, and they're all going to be the same color, and it's going to be difficult to see where one part stops and the other one starts. So on these parts, before you hand them off to your team members, give it a color, and the way we do that is in the part model. You can do it in the assembly model, but I prefer to do it in the part model. So when you assign your material, in this case it's 2024 T4, it tries to make the color of the part look like the color of 2024 T4 aluminum, which is okay, but they're all going to be the same silver gray color. The way you change the color of the part is hit the display manager. Right click on and you're going to be on the appearance manager here. Right click on that finish and say edit appearance. Instead of being satin finish aluminum, it's going to give you a pop-up with some colors, and then pick some pretty color. And then just make the whole part. You can make individual faces different colors, but I just like to make the whole thing one color. So grab a color, and you can pick only faces or only, I'm not sure what all you can do, but I just leave it on the default. The whole part is going to be red. I'll approve that. And then since this part reports to the assembly, now the color is red in the assembly. So that'll be nice. Everybody choose a different color so that all the parts have different colors. All right, so that takes us through step one. We will go ahead and put the rest of the parts all together, and then when we're done with that, we will watch the next video, which will be how to create that exploded view within the assembly model. That exploded view is not a separate file. It just lives in another spot inside the assembly model. So until then, enjoy.